Hello wolves, and welcome to Grade 5 Math, Chapter 2.4, Dividing by Tens, Hundreds, and Thousands. Multiply a 2, 3, or 4-digit number by a 2-digit number. Let's begin. The objectives for this chapter are: divide numbers by 10, 100, or 1000 using patterns, to divide numbers up to 4 digits by multiples of 10, 100, or 1000, and finally, learn to use rounding and related multiplication facts to estimate quotients. Let's get started. Just as it worked when we were multiplying by 10, there's an easily discernible pattern when you divide by 10. Let's use this example, 70 divided by 10. Now, if we think of this 70 as the same way we thought of it when we were working with multiplication, and we treated it as 7 groups of 10, all of a sudden this problem becomes very straightforward, right? We can see that the tens cancel one another out by becoming 1, and our answer is 7. So 70 is 7 groups of 10, therefore 70 divided by 10 equals 7. If we try the same thing with 160, we can think of 160 as 16 groups of 10. So 160 divided by 10 is 16. We can look at this in a place value chart to help us see what's happening as well. 70 in our place value chart will be represented by 7 chips in the tens place. 70 divided by 10 has an answer of 7, which would be represented by 7 chips in the ones place. So we can see that our 7 chips are simply shifting one place value to the right. Let's look at it again with 160. We would represent 160 in the place value chart as 1 chip in the hundreds column and 6 in the tens, with 0 in the ones. We know that 160 divided by 10 gives us an answer of 16, which we would represent as a 1 in the tens column and a 6 in the ones column. So we can see that our pattern, once again, is that each digit is being pushed one place to the right in the place value chart. Remember our rude cutting zeros in our place value chart when we were multiplying by tens, hundreds, and thousands? How those zeros just came in and pushed themselves to the front of the line in the ones, tens, or hundreds place? Well, this time we have the opposite problem with our line of digits. Let's say we have 1,800 as our beginning value. We'll represent that as 1 dot in the thousands, 8 in the hundreds, and none in the tens and the ones as they're represented by zeros. Well, when we divide by 10, what happens is that these digits in the thousands, hundreds, and tens place get impatient. They're going to push the digit in the ones place out the door so that they can be one place closer to the front of the line. So now our numbers move one place to the right, the thousands push to the hundreds push to the tens push to the ones, resulting in 1 0 dropping off of our number. So our pattern is, when you divide by 10, you drop 1 0 off the end of your number. It's that simple. A similar pattern emerges when we divide by 100. Let's try dividing 900 by 100. And let's watch what happens on our place value chart. If we were to put 900 into our place value chart, we put the 9 in the hundreds place and a 0 on each of the tens and the ones places. Now, we can also think of 900 as 9 groups of 100, right? So if we divide 900 by 100, that means we'll have groups of 9 left, which we will write on our place value chart as a 9 in the ones place. So you can see when we divided by 100 and when we were working with 2 zeros, we moved 1, 2 places to the right. Let's try it with another problem just to solidify this pattern for ourselves. Let's divide 1,400 by 100. So we'll begin by placing our 1,400 into our place value chart with the 1 in the thousands place, a 4 in the hundreds, and a 0 in each the tens and the ones. We can think of 1,400 as 14 groups of 100, right? So when we divide by 100, we know our answer will be 14, which will place a 1 in the tens place and a 4 in the ones place. Look again. Our 1 has moved two places over in the place value chart, and our 4 has moved 2 columns over in the place value chart. So what's our rule when dividing by 100? Whenever you divide a number by 100, you're going to remove 2 zeros from the end of that number to find your answer. So with 10, you take away 1 0, and with 100, you take away 2. Are you noticing a pattern? Let's divide by 1,000 to finalize the pattern. So if we have 9,000, we're going to represent that in our place value chart as a 9 in the thousands place, followed by zeros in the hundreds, tens, and ones. We can think of 9,000 as 9 groups of 1,000. So by dividing 9,000 by 1,000, we get an answer of 9. So as you'll see, with our 3 zeros in place, we're going to move our 9 over 3 places to the right in the place value chart. Here's another example. We would represent 14,000 in our place value chart with a 1 in the 10,000s column, a 4 in the thousands column, and zeros in hundreds, tens, and ones. We can think of 14,000 as 14 sets of 1,000. So when we divide by 1,000, our answer is 14, a 1 in the tens column and a 4 in the ones. So once again, each digit is moving 3 places to the right in our place value chart. So what's our rule when we divide by 1,000? When you divide a number by 1,000, you're removing 3 zeros, 1, 2, 3, from the end of that number to find your answer. So the rule is, when dividing by 1,000, take away 3 zeros. Let's explore dividing by multiples of 10, 100, or 1,000. 60 divided by 30. So we're dividing 60 by a multiple of 10, which is 30. We can do this problem exactly the same way we completed multiplication problems that looked like this. We're going to break the 30 apart into 3 units of 10. So let's rewrite this problem, breaking the 30 apart. So let's start with 60 divided by 10 divided by 3. I did this in a slightly different order than I did with the multiplication problems. In the multiplication problems, we left the 3 first. In division, we'll put the 10 first when we break these apart. It makes the division process a little bit easier. Because now, we'll divide 60 by 10. Well, we know 60 is simply another way to say 6 groups of 10. So our answer here is 6 divided by 3. Well, that's a basic division fact, so I hope you can all see right away that our answer is 2. 60 divided by 30 is 2. Let's try another. What is the quotient of 850 divided by 50? Once again, let's use breaking to help us solve this problem. 850, and let's rewrite 50 as 10 groups of 5. 850 divided by 10, well, our rule of 10 tells us we simply take off a 0, right? So now we have 85 divided by 5. What is 85 divided by 5? 17. Your answer is 17. And let's do one last example dividing by 10. This problem is 7,200 divided by 80. So 80 is our multiple of 10. So let's rewrite our problem as 7,200 divided by 10 groups of 8. If we're dividing 7,200 by 10, we know we simply need to take 1 0 off the end, giving us 720 divided by 8. Well, 720 divided by 8 would be 90. because 72 divided by 8 is 9, and then we put our 0 back on the end. So our answer is 90. Now let's divide by multiples of 100, using the exact same technique of breaking to help us solve the problem. What would 600 divided by 300 be? Well, we can think of 300 as 3 groups of 100. So we'll break the problem apart in this way to make it simpler to solve. If we're dividing by 100, we know that our rule is to drop 2 zeros. So our number becomes 6. 6 divided by 3 is 2. Therefore, 600 divided by 300 is 2. Here's an example using 1,000. What would 6,000 divided by 2,000 be? Once again, let's break the 2,000 apart to make this problem easier to complete. 6,000 divided by 1,000 groups of 2. That's how we'd rewrite this problem. Then we know if we're dividing by 1,000, we take away 3 zeros, 1 for each 0 in the 1,000. 1 goes into 6 times. So we have 6 divided by 2, giving us a final answer of 3. 6,000 divided by 2,000 equals 3. Wow, we've covered a lot in the last few minutes. Let's take a moment and practice some of these skills on your own. Use these problems 1 through 12 to practice dividing by 10, 100, and 1,000, as well as multiples of 10, 100, and 1,000. Please record your answers in your homework notebook. Hit pause, and I'll be back to talk about estimating to find quotients as soon as you're done. Here's our final idea for this chapter, and that is rounding to estimate quotients. How could we use rounding to estimate the quotient of 1,728 divided by 38? First, we'll round the divisor. Quick reminder, the divisor is the number you're dividing with. The dividend is the number that you are dividing into. We'll begin by rounding our divisor, which is 38, to the number 40. Now, we want to think about complementary facts here. Just as we did with multiplication, looking at complementary basic division facts will help us to speed up this process. Is there a number close to 17 that is easily divisible by 4? I can think of 2. 16 divided by 4 gives us an answer of 4, correct? And 20 is also close to 17 divided by 4 gives us an answer of 5. Which is closer to 17? 16 is closer, so we want to use 16 to estimate our quotient. So our problem becomes 1,600 divided by 40. If we break that problem apart to solve it, it becomes 1,600 divided by 10 divided by 4. Using the rule of 10, 1,600 becomes 160 divided by 4, giving us a final answer of 40. 1,728 divided by 38 is about 40. Let's try another problem like this. Let's estimate the quotient of 4,367 divided by 670. Once again, we'll begin by rounding the divisor, 670, to the nearest hundreds, which would be 700. Now we can ignore the 67 for just a moment while we focus on 43. Once again, we're going to look for complementary facts where 7 would go into a number that is close to 43. Look for the number above and below that is divisible by 7. So we know that 42 is divisible by 7, giving us an answer of 6, correct? And that 49 is divisible by 7, giving us an answer of 7. So which number is closer to 43? Well, that's quite clear that 42 and 43 are closer together. So our problem is now rewritten as 4,200, we're going to give these two digits back now, divided by 700. We'll rewrite that by breaking. By rule of 100, we're going to take away 2 zeros, so we come up with 42 divided by 7, whose answer is 6. So 4,367 divided by 670 is approximately 6. Finish up today's lesson by trying these 4 problems on your own. Please estimate the quotients by using compatible numbers to help you. Be sure you're rounding each number to the highest possible digit. For example, 987 would be rounded to the nearest hundreds, or in this case thousands, hint hint, and 17 would be rounded to the nearest tens place. Please show your work so I can understand your math thinking. Record all of this in your homework notebook. Great job on today's lesson, and I'll see you tomorrow to begin our next steps in division.